allowed by default. So when I install a third-party application, all the green things I can access with that third-party application. The yellow things are going to prompt, and the red things are going to be inaccessible to me. The bottom row there is the important row. Email data, organizer data, files. You can access a lot of the content on the phone by default without getting a trusted access permission. This is a 5.0 version, so they changed it a little bit. They added a couple of boxes here, but again, the bottom row, email data, organizer data, files, that stuff's all accessible to the application. And this is without pressing the little prompt that says, do you trust this application? This is by default. Now, again, you can go through and harden all this, and you should. But if only 23% of the people are even using any kind of security on their phone, what percentage are going to go through on an application-by-application basis for applications that they're downloading from the App Store that they think are safe in the first place? Very few.
The problem is if you take away file permission, it can't even access its own files.
So it's got its own problems, too, if you start to harden it. I mean, the right thing might be to do is to make them all yellow, right? So that the first time you run the application, you don't say yes to the trusted, you make them all yellow and it prompts you. So that when you install your tic-tac-toe game and run it and it says accessing contact data, you can say, no, you're not, and turn it off. Or you can say yes because you want to share your contact data with tic-tac-toe, and you can check the little box that says always allow this, and you'll only be prompted once. So let's look at trusted for 5.0. Looks pretty much the same. Still largely a problem. It's going to end up being a problem of user education and default security settings to limit the effectiveness of spyware on these devices. The good thing is RIM has the options to make this happen. Other platforms don't even have the option at this point to make these types of things happen. So RIM is in a unique position to really secure and shore down the devices themselves. So let's talk about installation methods. This is not a worm that I wrote. This is not a virus that I wrote. It does not propagate itself. It only tries to hide itself minimally. For example, when its command and control channel is over SMS, I do not hide the inbound SMS messages. They will appear in the victim's inbox, and that's intentional. So installation methods were not necessarily something I was researching as far as trying to exploit the device or anything like that. That wasn't my goal. That being said, we should talk about them. Common installation methods for applications in general are accessing a website using the Blackberry browser and doing an OTA over-the-air installation of the application by using the JAD file. Running the application loader tool at the Blackberry desktop and pushing it from the actual PC itself to the device. You can do a Blackberry Bez push of the application to the user community. Or the most important one is get it into the Blackberry app world and let the user do it for you. That way you don't have to compromise, you don't have to social engineer, you don't have to do anything. Just push it up to the Blackberry app store and make it look really nice and pretty, and then grab all the user's data. The app marketplaces across the board are generally operating in a browser beware stance. You get what you pay for, guys, with regards to the security of these applications. Think 2 cows in 99, think shareware sites in 99. If everyone went through a single shareware site back in 1999 and we could have secured those shareware sites for all of the applications, we would be in a great position now with regards to shareware, or with regards to malware. We got a unique opportunity here. We need to embrace it and use it. So the installation files themselves are the code files. It's a proprietary format developed by RIM. It contains the compiled and packaged application code. We have the JAD files, which is essentially a descriptor that provides pointer and information metadata about the code file, holds a URL pointer and other items. That one's required for over-the-air installation. We have a jar file, which is exactly like a Java jar file. It's the same thing. Multiple classes, metadata, those types of things are in it. That's not required for the installation of the application. And then an ALX file is an XML-based application descriptor file. Very similar to the JAD, it contains a pointer to the code file along with some application metadata, and that's used for the BlackBerry Desktop Manager Java loader-based installation of applications. What? That's me in the morning. I failed to mention, thanks to Jack Daniel in the back, if anybody does need hangover medicine, we have it. So, all right. So effects and behaviors of my spyware, which I call txsBBSpy. What does it do? So I took all this information, I took all these ideas, these concepts, and I went through the BlackBerry API. Somebody needs hangover medicine. And wrote a proof of concept reference implementation of a Blackberry spyware application. Again, does not try to hide itself. It's noisy on purpose. It demonstrates how to program a piece of spyware for the Blackberry device. I did implement hiding from the little process list thing, and I did implement the code that when you reboot the phone, it'll auto-run, and it also runs as a system module. So I did implement those things, but I didn't release how to do that, although it's not very hard to figure it out yourselves. So I'll let you guys figure out that piece of it. And one other thing to note is I'm only releasing this in source code format. I am not releasing the binary of this. I don't want to sign a malicious binary with my key and push it out there. So you guys have a little bit of barrier to entry. You've got to compile it yourself and sign it yourself and deal with the fallout of that yourselves. So what do I mean by fully functional? What does my application do? It monitors connected, disconnected calls in real time. It can exfiltrate your contacts, your email, your GPS location, your phone logs, can turn on the microphone and capture data through the microphone and send that out as an AMR file. It can monitor a bunch of this in real time and have the data sent off the device, and it can monitor it as single point in time dumps of whatever the contact list currently is. Oops, oh no, wrong button. There we go. And how does it get the data off the device? We have a number of different exfiltration methods and a single command and control method, which was, again, intentional. But exfiltration-wise, we can send the data off the device via SMS datagrams, email, HTTP GET, HTTP POST, TCP sockets, UDP sockets, whatever method you want to exfiltrate the data off the device, it's within the code. You can see how that's done. I did bind the command and control channel to inbound SMS only. That's trivial to modify, guys. If you want the device to fire up and connect via TCP socket to some external place and send data across that, you guys can figure out how to set that up just by looking at the TCP exfiltration code. So let's get all techie here, all nerdy with the glasses on, and talk about some actual code. It goes into detail about a few of the options, not all of them, due to time constraints and how the code actually operates. So technical methods. I broke it up into 3, possibly 4 technical methods. We have the data dumpers, the listeners, the exfiltration methods, and the command and control. Data dumpers are the one-time data retrieval functions. The fire and forgets, you fire in your command, and it comes back and says, here's the answer. The listeners are real-time monitoring components where you fire in the command and it turns on that listener for that particular thing of interest. And it's on until you turn it off. And then the exfiltration methods are the multiple different ways that we went through to have the data be sent off of the device. And then finally, the command and control channel. So I'm going to go through, I think, 2 dumpers, 2 listeners, and then 2 exfiltrators. Like I said, there's more than that, but just for sake of time and to be able to show you a little bit of a demo at the end, I'm just going to go through a couple of them. But you see at the top the important APIs when dumping contact information, the Java Micro Edition PIM, which is the Personal Information Manager API, and also the PDAP API, which is the Personal Digital Assistant Profile API, are the ones that we use here for this exfiltration, or for this capturing of contact information. And using these APIs, we get an instance of the PIM, which is the information manager, and then an object that holds the contact list in read-only mode. And we enumerate through the items in the contact list and send it to our, if the field is something we're interested in, we then send that field to our exfiltration method and send the data outbound. Pretty straightforward. Here's another example of a data dumper. This is the dump microphone example. One thing that's of interest, I don't know if you guys caught it when we were going through the grid of permissions. Recording was yellow by default and by trusted across the board for 4 and 5. So this one, or it was set to prompt. So this one actually requires you, it's going to prompt the user. So that's something to keep in mind with the dump mic stuff, is it's going to prompt the user and say, this is trying to access your microphone. So it's a point to keep in mind. So in this example, we enable the microphone on the phone and listen to the ambient room noise. After a set amount of time, which I actually have configurable in a, I don't know if I released that part in the source code, but it's configurable in the current SVN tree. We close the microphone after that specific amount of time and save the data and exfiltrate it. We base64 encode it and send it off the device as a big blob in email or however you're sending it off.